Hello friends, in today's lecture what we'll be doing is we will be learning how to solve an ordinary differential equation, that is the boundary value problem, in C programming. So let us take one example. Let's say that we have a differential equation dy by dx is equal to e to the power x, and when let's say x is equal to 0, y is equal to 1. So if you solve this equation analytically, so how to solve this? Dy is e to the power x dx, and when x is equal to 0, y is 1, and when x is some x, y is y, so it becomes y minus 1 is equal to e to the power x minus e to the power 0, and e to the power 0 is 1, so y will come out to be e to the power x. So the solution of this equation is going to be y is equal to e to the power x. Now how to solve this using programming? So the x is starting at 0 and let's say it is ending at 1. So this is my x which is starting at 0 and ending at 1. To take certain number of nodes, let's say 1, 2nd, 3rd, 4th, 5th, then 6th, and then 7th. So 7 nodes at equal distances, so that these 7 nodes will divide the whole domain, that is 0 to 1, in how many equal parts? So if n is equal to 7, then these parts will be 6. Okay. Now, I have already discussed with you that how to evaluate this dx. So this is the domain length, that is 1 minus 0 divided by n minus 1. So now what you can do is you can run a loop to evaluate x. So for I0, I less than n, I plus plus, your x will be, ith value of x will be what? Will be equal to I times dx. Okay, this you have done earlier also while solving that projectile motion. Now how to solve this? For indexes 1 to this n minus 1, because n is the number of node and our index is starting at 0, so this will be n minus 1. So for 1 to the last, we have to solve this equation, because for this node, that is x is equal to 0, we already are having the value that when x is 0, the value x is 0, so the value of y at this node is going to be 1. Okay. So now let us use Euler's method. So let's say, let us consider these three. So if I consider these three nodes, so this is node number 1, this is node number 2, this is node number 3. So if I want to know, and let us also consider node number 0. So if I want to know the value at node number 1, what I can do is I can find out, I can use the backward difference. So y1 minus y0 divided by dx is equal to e to the power x, but this value I don't know. So what I'll be doing is I will be considering this as x0. So y1 will be equal to y0 plus dx e to the power x0. In a similar ground, what I can write about y2? y2 will be y1 plus dx e to the power x1, because y1 I know, so I can plug in here. So therefore the general expression for the ith node, any ith node, will be what? For any ith node, the expression will be yi is equal to yi minus 1 plus dx times e to the power xi minus 1. That's it. And the accuracy of this method will be lying on the number of nodes. The more the number of nodes will be, the better the accurate result we'll be getting. So let us directly head to the editor and solve this and try to see how we can implement it. So first let's define x having n number of nodes. Okay. Likewise y having n number of nodes. Now can we do this? Yes, we can do this provided we already have defined this n. So int n is equal to how many nodes? Let's say we take, well, let's ask the user how many nodes he want. So printf, enter the number of nodes, and then scanf, transferring it to the address of n. Now what about x? So this is done. Once this is done, you will be requiring dx also, and you also will be requiring the length of domain. So let's say that the length of the domain is L, and that L is equal to 0. So starting with 0 and ending at, sorry, not 0, 1. So make it capital L. Okay, now it's looking. So length of the domain is 1, starting at 0, x is equal to 0, and ending at x is equal to 1. Okay, now evaluating this dx. So dx will be equal to L divided by number of nodes minus 1. Okay, then evaluating the array of x. Okay, we can do that inside the loop also, that's not a problem, but still. So for int I is equal to 0, I is less than n I plus plus, and inside what is your xi? The xi is going to be I times dx. That's it. Okay, now once you know this, it is time to get the initial condition. So what initial condition you are having? When x is equal to 0, y is equal to 1. So initial condition. So when x is equal to 0, y is 1. So y at the 0th node, that is at the 0th index, is going to be equal to 1. Okay, now if you look this, so this has to be solved for all the node except this node, because this is the initial condition which we already know. So for int I is equal to 1, I is less than n, I plus plus, what you have to do? You have to simply say y at ith node will be equal to y at I minus 1th node plus exponential of x at I minus 1th node times dx. Let us look at once more. It is yi is yi minus 1 plus dx times this. So yi is equal to yi minus 1 plus dx times e to the power xi minus 1. So done. That's it. Now if you want, you can do what? You can set the exact value also, and let's say the exact value of y exact I'm also writing here. So that is comma y exact, let us make it of array n, and we can evaluate it inside this only. There's no need to write a separate loop for it. So y exact I will be equal to what we have evaluated. We have seen that the exact analytical value was e to the power x. So it will be exponential of xi. That's it. So done. Now you are in a position to print the result. So printf. So let's say serial number, and then give a tab, then your x, okay, it will be xi, not xi, x, and then y, numerical, है ना? Then give a tab, and then here also you should give a tab, and then y exact, ex, okay, and then new line. So this is our header now, and then make one line so that the program can look better, and then for int I is equal to 0, I is less than n, I plus plus, what you have to do? You have to printf. Now first what will come? First serial number will come, so it is %d, then give a tab, then what? Then x will come, so it is %f. Now let's restrict ourselves to 2 places of decimal, and then again give a tab, then what? Then y numerical value. Y numerical means this y will come, okay. So if you don't want to write numerical, leave it. Then so this is your serial number, that is I, this is for your x. Now we'll be writing y, so it is %f, again take only 2 places after decimal, and then again give a tab, and then comes the exact value, so 0.2. So this will be, first I will come, then x will come, okay, then first I will come, then x will come, then y will come, that is the numerical computed y, the one which we have done using numerical computation, and the one which you are getting using the analytical result, that is y exact. So this is y exact I, and then for after printing this, one should move to next line, okay. Then to complete this table, let us print this again. I think it's done. So let us run the program. No, it's not done because exponentiation is only defined in math. So that has to be included, math.h. Now let us run it. So it is saying something. It is saying what? Error, expected colon. Okay, we have not finished, we have not completed this statement. Okay, then now run it. So how many nodes you require? Let's say I require 7 nodes. So let us again do what? Let us come here. So it is 0.2f. So 7 nodes. Okay, now it's done. Now you can see as x changes, with every passing x, you are getting some value from the numerical result, that is yi is yi minus 1 plus dx into e to the power xi minus 1. So this is the result, and this is the exact result. Now you can see that there is a deviation. Why this deviation? Why this value is less than the exact value? The reason being we have taken lesser number of nodes. So if I increase the number of nodes from 7 to let's say 70, then you will be in a position to appreciate that the difference becomes very less. So it is 1.01, 1.03, 1.04 and so on. So you are getting almost the same values. Okay, so in this way you can solve any first order differential equation uh, using your arrays and loops. So in this lecture, till this point only, thank you very much for watching it.